making looms to making automobiles, today we are planning a new chapter for Toyota.
Think about refueling your vehicle in about 5 minutes in order to go on a long road trip, or better yet.
The automotive world is buzzing with a new contender that could shake the very foundation of the EV industry. Hydrogen combustion technology has quietly been gaining momentum, and it promises to do what electric vehicles never could: combine sustainability with sheer power and efficiency. While EVs have dominated the green revolution headlines, this alternative might be the game changer we've all been waiting for. But how does it work? And why are experts saying it could dethrone electric vehicles? Let's dive into the future of transportation with hydrogen combustion. But hydrogen technology isn't just a dream for the future, it's already here. And one automaker is leading the charge. Toyota, a pioneer in hybrid innovation, is now challenging the electric vehicle trend with a bold vision. Could hydrogen fuel cell vehicles truly change the game? Why Toyota is rethinking electric vehicles. The technology behind hydrogen fuel cell vehicles produces only water as a byproduct, making them a more sustainable and environmentally friendly alternative. For years, the automotive industry has invested significant resources into developing these vehicles, with several manufacturers unveiling their own models. However, despite their clear advantages, widespread adoption remains challenging. Currently, fuel cell vehicles are more expensive than their gasoline-powered counterparts, and the infrastructure for producing, transporting, and distributing hydrogen fuel is still underdeveloped. Since it launched the revolutionary Prius in 1997, Toyota has been a leader in hybrid and plug-in hybrid vehicles, which paved the way for the current electric vehicle craze. However, despite its roots, the Japanese brand has been hesitant to jump headfirst into the all-electric trend. Toyota's first 100% electric vehicle, the awkwardly named BZ4X, has sold only a few hundred units as of mid-October, and the Japanese car maker doesn't plan to ramp up production until 2025. Toyota's slowness in adopting all-electric vehicles was reinforced by the company's president, Akio Toyoda. Here's Toyota president's view on the future of the auto industry. As the Wall Street Journal reports, people involved in the auto industry are largely a silent majority, Toyota said. That silent majority is wondering whether electric vehicles are really okay to have as a single option. But they think it's the trend, so they can't speak out loudly. Because the right answer is still unclear, we shouldn't limit ourselves to just one option. Although that sentiment is controversial, it merits consideration. All electrics amount to only a fraction of the total new car market, which leaves the market open for another kind of vehicle, which is the direction Toyota has chosen. Let's take a closer look at this type of engine, the hydrogen combustion engine, and see why Toyota executives think it can potentially make EVs obsolete. While some automakers hype up electric vehicles that won't come out for another several years, Toyota does the same with combustion engines. Well ahead of their introduction in production cars, the new 4-cylinder ICEs were unveiled as work-in-progress developments at the end of May. Now, the Japanese automaker's chief technology officer is providing more details about what lies ahead. Toyota's approach to hydrogen isn't just about reimagining the future, it's also about proving it on the track. With a bold leap into motorsports, Toyota has tested the limits of hydrogen combustion technology in high-pressure racing environments. But can lessons from the racetrack translate to everyday streets? Let's find out. Racing heritage. Toyota's chairman and former CEO, Akio Toyoda, pushed for the development of a hydrogen-powered racing car. Rather than creating a fuel cell vehicle like the pioneering Mirai, Toyota's engineers sought a way to make the concept viable in a combustion engine. They settled on the 1.6-litre 3-pot engine used in the GR Corolla. The car was later entered successfully in the Super Taikyu series. One of the challenges the company faced was balancing thermal efficiency with hydrogen burning faster and hotter than gasoline. However, using lessons learned from the hydrogen-powered GR Corolla racing car, Toyota's engineers have cracked how to make these engines even more efficient for the street. Chief Technology Officer Hiroki Nakajima said Toyota's experience in developing the hydrogen racer fed directly into these future production engines. Speaking with Automotive News, he referred to the new 1.5-litre and 2.0-litre engines as a potentially game-changer solution. He went as far as to say they'll be completely different compared to the current crop of ICEs. While hydrogen cars haven't really taken off, Toyota says the development work done for the slow-selling Mirai has helped the engineers learn more about engine heat efficiency. Nakajima didn't mention thermal efficiency specifics, but Toyota hit 40% several years ago. Nissan touts an even higher 50% thanks to its e-power technology, with the combustion engine serving as a generator to feed a battery instead of driving the wheels. Another Japanese automaker, Mazda, has taken a similar approach with the rotary engine inside the MX-30, a range-extending electric crossover. A new generation of engine, Toyota, has developed a highly efficient combustion engine that can use gasoline, synthetic fuels, biodiesel or hydrogen that will fend off EVs for years to come. The new technology is a result of insights gained from racing the hydrogen-powered GR Corolla. Despite the rise of electric vehicles, Toyota continues to invest in internal combustion engines. The company has come under fire for being anti-EV and has even been accused of weakening nations' climate policies through industry advocacy groups. Despite teasing the world with promises of a solid-state battery and introducing its own electric vehicles, the company remains committed to furthering existing tech with a multi-pathway approach to reducing emissions. The Japanese auto giant's goal of carbon neutrality involves not only battery electric vehicles, but plug-in hybrids, conventional hybrids, and internal combustion engine cars. The company also remains committed to developing hydrogen technologies. This furthering of hydrogen tech, it says, has resulted in the creation of a new breed of thermally efficient engines that can run on a variety of fuels, including conventional gasoline as well as carbon-neutral options such as synthetic e-fuels, biodiesel, and hydrogen. Toyota's engineers claim that thanks to engineering advances, these new engines can be 10 to 20% physically smaller than they are today, but, crucially, are more fuel efficient and can produce more power. While the concept can run on a variety of fuels, including hydrogen, the short-term goal is to incorporate these new efficient engines into a hybrid drivetrain. A 1.5-litre engine with turbo and naturally aspirated configurations and a 2.0-litre turbocharged version have been developed. The new engines will have shorter strokes and less torque. But as they're designed to work in conjunction with a hybrid system, the electric motors will fill in any gaps, at least with our enthusiast's cap on. The trade-off will be fewer revolutions per minute. Specs are being kept under wraps for now, but the engines will likely start to appear in time for new Euro 7 emissions regulations that require stricter emissions control from gasoline engines. In the long term, the plan will be to develop an engine that runs on carbon-neutral fuels. How hydrogen cars work. Hydrogen fuel cell vehicles function through a straightforward process that converts hydrogen gas into electrical energy, which in turn powers an electric motor. The heart of this technology is the fuel cell, composed of several layers of materials, including a proton exchange membrane, an anode, and a cathode. Hydrogen gas is introduced at the anode, where it undergoes separation into protons and electrons. The protons traverse the membrane to reach the cathode, while the electrons are directed through an external circuit. This flow of electrons generates an electric current, which subsequently propels the motor. Oxygen from the surrounding air enters the cathode, combining with the protons and electrons to produce water vapor, the sole emission from these vehicles. Hydrogen fuel cell vehicles require a constant supply of hydrogen gas stored in high-pressure tanks. Consequently, refueling these vehicles is akin to the process of refilling a gasoline vehicle and can be completed in a matter of minutes. The origins of hydrogen fuel cell vehicles can be traced back to the early 1800s, when scientists began delving into hydrogen as a serious subject of study. However, it wasn't until the 1960s that researchers started developing fuel cell technology suitable for automobiles. Notably, in the embryonic stages of this industry, General Motors introduced the Electrovan in 1966, a vehicle powered by a fuel cell designed to assess the feasibility of employing fuel cells as a source of power for vehicles. The Electrovan was equipped with a 32-kilowatt fuel cell, which supplied power to an electric motor driving the vehicle's wheels, boasting a range of approximately 70 miles and a top speed of 70 miles per hour. It wasn't until the 1990s that automakers like General Motors and Toyota ushered in the era of modern hydrogen fuel cell vehicles. The hydrogen fuel cell vehicle sector has witnessed substantial growth in recent years, with automakers continually investing in this technology. In 2020, Toyota achieved sales exceeding 10,000 units of its Mirai fuel cell vehicle. and other manufacturers such as Honda and Hyundai have also introduced their fuel cell models. This increased availability of fuel cell vehicles has been accompanied by advancements in the infrastructure necessary for hydrogen fuel production and distribution, resulting in more hydrogen fueling stations being established across the US, Europe, and Asia. Nonetheless, challenges persist in the quest to render fuel cell vehicles more economically accessible and expand hydrogen production and distribution infrastructure. In addressing these challenges, automakers have joined forces with energy companies and governments to expedite the development of fuel cell technology and infrastructure. The Corolla Cross H2 concept. The Corolla Cross H2 concept has been introduced and is likely to come to market in the next few years. The Toyota Corolla Cross H2 concept uses a new prototype hydrogen internal combustion engine, abbreviated ICE, car called the Corolla Cross H2 concept. Power comes from the hot 1.6-litre turbocharged 3-cylinder used in the GR Corolla and GR Yaris, which are converted to using hydrogen as a fuel. To begin with, thick, armoured fuel tanks are required to hold the highly flammable hydrogen technology that Toyota gleaned from its FCEV, a fuel cell electric vehicle, the Mirai. The engine gets hardened valves and valve seats, stronger connecting rods, and fuel injectors designed for gas, not liquid. Like a standard Corolla, the Cross H2 concept has room for 5 passengers and their luggage. Toyota isn't stopping with compact concepts. What if hydrogen power could deliver the roar of a high-performance V8 engine? With its sights set on redefining muscle cars, Toyota's next project promises to blend sustainability with exhilarating power. Let's dive into the groundbreaking hydrogen V8 collaboration with Yamaha. A large hydrogen-powered V8 is in the works. Toyota has partnered with Yamaha Motor to develop a hydrogen-powered V8 engine. In exciting news to gearheads everywhere, Toyota has partnered with Yamaha Motor to develop a hydrogen-fueled V8 engine. In an announcement earlier this year, Yamaha said the 5.0-litre V8 would be based on the one used by the Lexus RC Coupe, with modifications to its cylinder heads and fuel injectors, among other things. Yamaha claims it'll produce 455 horsepower at 6,800 revolutions per minute and 398 pound-feet of torque at 3,600 revolutions per minute. That's a bit less power than the original gasoline V8 that it's based on, but still quite respectable. However, the most stunning feature of the hydrogen V8 is the 8-into-1 top-mounted exhaust manifold, which Yamaha claims creates a distinct high-frequency sound. Why the hydrogen combustion engine? Refueling a hydrogen vehicle is much faster than charging an EV. You have to admit that even though filling up your gas-powered ICE vehicle may not be the highlight of your day, it is not rocket science. Filling up a hydrogen-powered car is just as easy, but does not take nearly as long to accomplish because it is a gas rather than a liquid. If you have ever had a propane tank filled, not traded out for a new one, you understand how fast the process will be. In fact, the new Toyota Yaris GR-H2 only takes a minute and a half to fill completely full of hydrogen, which is much faster than it would take to fill the tank on a Toyota Camry with unleaded. Hydrogen vehicles offer a distinct advantage in terms of range when compared to electric vehicles. While some electric cars can cover around 300 miles on a single charge, specific hydrogen models can surpass the 400-mile mark. If range is your top priority, hydrogen cars can be an appealing choice. When it comes to refueling, hydrogen cars undeniably provide a more convenient experience. A quick stop at a hydrogen refueling station takes only a matter of minutes, ensuring you can get back on the road swiftly. On the other hand, recharging an electric car can be a considerably more time-consuming process, potentially taking hours. If your time is precious and you prefer not to wait around, hydrogen might be the preferred choice for you. In the realm of performance, hydrogen cars excel by consistently delivering optimal power output throughout your entire journey. This reliability sets them apart from electric vehicles, which often experience a noticeable decline in performance as their batteries deplete. The uninterrupted and smooth driving experience offered by hydrogen vehicles isn't merely a matter of convenience. It can be a significant factor to consider when selecting your preferred mode of transportation. This consistency in power delivery means that hydrogen cars maintain their acceleration, handling, and responsiveness from the moment you start your journey to the very end, ensuring a predictable and confidence-inspiring driving experience. In contrast, electric vehicles may lose their initial vigor as the battery charge diminishes, potentially affecting acceleration and overall performance, especially during extended drives. Therefore, if you prioritize a driving experience that remains consistent and dependable regardless of the distance you need to cover, hydrogen vehicles present a compelling option. Hydrogen has a broad climate adaptability. Hydrogen can withstand up to -435 degrees, making it one of the more climate adaptable. Diesel fuel has long been used in vehicles that need to be used for hauling and towing excessive loads, but they can freeze in areas where the temperatures drop down into the negative double digits. Thankfully, unleaded fuel can withstand temperatures of up to -100 degrees Fahrenheit, which can be caused by some cold wind chill factors. Lithium batteries can withstand up to -140 degrees Fahrenheit before they start to freeze up, which can still occur occasionally. Hydrogen can withstand -435 degrees Fahrenheit, which shows it is the best choice in cold temperatures worldwide. The same holds true when comparing the hot end of the spectrum. Hydrogen has a much broader climate adaptability than the other two options currently available. Hydrogen fuel systems avoid material scarcity problems. Because lithium batteries can be challenging to produce, hydrogen could make for the perfect alternative. Lithium batteries are not made out of materials that can easily be produced. In fact, many people, such as the CEO of Toyota, former CEO Akio Toyoda, see a shortage of lithium and battery-grade nickel, which means that there will be a lack of materials needed to produce the lithium batteries used in EVs. That could create a major setback in the move towards electric vehicles, which could be avoided by using hydrogen-powered engines if they are engineered to maximize their full potential. Hydrogen-driven engines sound and respond like fuel-driven engines. Hydrogen vehicles can give the same rumble as gas-powered cars. Sound is one of the biggest complaints you may have with EV cars and trucks. If you have ever driven an old classic muscle car, such as a 1970 Chevrolet Chevelle SS with a big block 454 or a 1969 Ford Mustang with a 428 Cobra Jet, nothing can compare with the excitement as you press the accelerator to the floor. The sound as the carbs open up and the fuel rushes into the chambers. Power rushes through your chest as soon as the horsepower hits the drivetrain, and adrenaline hits in full as the car launches. EVs cannot give that to you, but a hydrogen-powered car can, because it works in the same general way. Hydrogen engines are completely mechanical. Hydrogen-powered vehicles still heavily rely on mechanics. They're better for that industry's long-term health. Small local mechanic shops can be found on almost every corner across the country. But as EVs become more popular with consumers, those small garages will no longer be an option for you. They may be able to go online, watch a few YouTube videos, and figure out how to repair your electric engine. Still, it is highly suggested that you take it to a registered mechanic familiar with the new technology. The great thing about hydrogen-powered engines is that since they are so similar to fuel-powered engines, they are entirely mechanical. That means that those small corner shops that you are comfortable taking your vehicles to will be able to work on them. This technology has a checkered past. The concept of hydrogen-powered vehicles has been around for decades, with BMW being one of the first major automakers to try creating a model using this build. The concept of powering an internal combustion engine with hydrogen is not new. Most notably, German automaker BMW produced the 750 HL in 2002, followed by the Hydrogen 7 in 2005. The Hydrogen 7 was based on BMW's traditional gasoline-powered 6.0-litre V12, but with modifications to burn hydrogen and gasoline. That technically made it a dual-fuel engine, and only 100 of them were produced. Some downsides to hydrogen are that it's highly flammable, difficult to process and store, and the combustion process emits nitrous oxide. While hydrogen-powered engines have their hurdles, electric vehicles are far from flawless. Rising energy concerns and global conflicts are exposing cracks in the EV revolution. Could Toyota's balanced strategy hold the key to a more sustainable future? Let's examine the challenges EVs face in today's energy landscape. EVs are not without fault either. Electric vehicles still use energy to charge, with some countries regulating them more severely. As opposed to almost all the other automakers who are betting everything on electric cars, Toyota's approach to carbon neutrality is more diversified. evaluating multiple technologies to achieve the goal of zero emissions. This ethos seems increasingly prescient when considering that with the war in Ukraine and its impact on energy supplies, European countries are looking for ways to cut energy use. In fact, Switzerland has gone so far as to encourage EV drivers to only use their cars for urgent needs, like going to work or the grocery store, and it could be codified into law. Hydrogen cars offer a clear advantage when it comes to reducing environmental impacts. The environmental benefits are substantial, particularly when hydrogen production aligns with clean and sustainable methods. When hydrogen is generated through processes like electrolysis, powered by renewable energy sources such as wind, solar, or hydropower, it can result in zero direct greenhouse gas emissions. This makes hydrogen cars a key player in the ongoing efforts to combat climate change. Even in regions where hydrogen production relies on natural gas, technologies like carbon capture and storage, CCS, can help reduce carbon emissions, making hydrogen cars more eco-friendly than conventional internal combustion engine. This reduction in carbon emissions is a notable point in favor of hydrogen cars. Hydrogen fuel cell vehicles are indeed zero-emission vehicles, emitting only water vapor. However, it's essential to consider the production of hydrogen gas. Hydrogen can either be sourced sustainably or from methods that emit greenhouse gases, sometimes with cost advantages. This underscores the importance of using sustainable hydrogen production methods to maximize the environmental benefits. Nonetheless, it's important to recognize that both the manufacturing and transportation of hydrogen gas require significant energy and infrastructure, which comes with its own environmental implications. These aspects need to be carefully considered and improved upon. Despite these challenges, hydrogen fuel cell vehicles have the potential to reduce greenhouse gas emissions significantly in the realm of transportation. As technology and infrastructure continue to evolve, the environmental consequences of hydrogen fuel cell cars are expected to become even more favorable. With ongoing innovations, the goal of a more environmentally responsible future on the road comes closer to reality, positioning hydrogen cars as a sensible choice for reducing the environmental impact of transportation. The 2023 Mirai is making headlines. Toyota has released its hydrogen-powered vehicle, Mirai. With Toyota investing heavily in hydrogen power, we're seeing more models come to market using it as a power source. For example, the 2023 Mirai is hydrogen-powered and has already started rolling off production, hitting dealerships, being driven by people throughout California, and being sold in Europe. Hydrogen-powered cars are still very new to the scene, but demand continues to grow for them. That said, worldwide, Toyota sold 1,674 Mirai vehicles in the first 5 months of this year, a 13.3% fall on the same period in 2022. More people feel safe in an EV, for now, so this will require re-education of markets where hydrogen is sold. Many believe your next vehicle should be hydrogen-powered, but it's not enough. Toyota is placing huge bets on hydrogen at its US plants. Toyota has dedicated various US facilities to testing and perfecting hydrogen-powered cars. With Toyota rapidly moving in the EV, PHEV, and hydrogen direction, it's worth noting that some of its US factories will see fuel cell batteries manufactured inside of them. According to a press release from Toyota, a dedicated line at Toyota Motor Manufacturing Kentucky, TMMK, will begin assembling integrated dual fuel cell FC modules destined for use in hydrogen-powered, heavy-duty commercial trucks. This is likely to spread to other US and global facilities as Toyota ramps up hydrogen production. Hydrogen vehicles won't explode or catch fire as easily as lithium-ion batteries. Hydrogen has been deemed safe for car manufacturing by Toyota, as well as many independent studies. One of the top safety concerns with hydrogen energy being used at the commercial level has been the risk of explosion. Some experts claim a hydrogen explosion resembles more of a bomb than a typical spark and fire, which has caused people to be wary. However, compared to the frequency of lithium-ion overheating or reacting poorly to environmental conditions, hydrogen, when handled correctly, can be a safer, less reactive energy source. It's also worth noting that hydrogen gas itself is 200 times lighter for the same amount of energy as lithium batteries. Hydrogen stores even more energy than gasoline, so that it can be a vital source of energy for even large-scale consumption. Hydrogen means your car will last longer. Hydrogen vehicles tend to break down less than gas or electric cars. Mixed with Toyota's engineering and ability to produce fuel cell technology at a mass scale, we could easily see hydrogen vehicles breaking down less and requiring fewer trips for maintenance. Although hydrogen cars are powered by electric motors, they won't be solely focusing on charging, battery health, and eventual degradation. The same comparison can be made to ICE, with regular engines eventually breaking down and failing. Hydrogen, although currently difficult to work with, can become simplified with enough testing and investment from brands like Toyota. The fuel cell stacks are designed to last the vehicle's lifetime, which is about 150,000 to 200,000 miles. Once your hydrogen car dies or you're done with it, the fuel cell will be disassembled and the materials recycled, similar to what happens with vehicle components today. There are currently 10+ hydrogen cars in the works, so it appears to be a race to the finish line for auto manufacturers. Toyota has joined forces with other investors in its race to perfect hydrogen combustion engines. Toyota has joined the Hydrogen Council, investing money into a $5 billion initiative to bring this energy to the masses by the next decade. As part of creating and perfecting hydrogen combustion engines, Toyota has seen investors interested in the concept. The emergence of the Hydrogen Council, a global consortium comprised of top executives from prominent companies in the fuel, energy, manufacturing, and mining sectors, underscores the growing importance of hydrogen. Members of the council, such as Air Liquide, Alstom, BMW, Daimler, Shell, and Toyota, have collectively committed $5 billion for hydrogen-related investments over the next 5 years. Their objective is to streamline and accelerate hydrogen investments across various industries into the next decade. Toyota has the time, money, and power to do this. With Toyota pouring billions into the future of hydrogen, the company is setting the stage for a global energy shift. However, while the US waits, Europe and China are already embracing this breakthrough. Will these regions be the testing grounds for Toyota's bold hydrogen bet? Let's explore the ambitious plans for the next decade. Toyota bets big on hydrogen cars in Europe and China. Toyota hopes to sell 200,000 hydrogen vehicles in Europe and China by 2030. However, we have seen the Mirai pop up in California and the US, and Toyota's main focus for hydrogen vehicles remains in China and Europe. The company will focus on rolling out hydrogen-powered vehicles in Europe and China, with the aim of selling 200,000 units by 2030. This is a massive goal for the Japanese brand to set for such a new technology, but they're known to push the limits. Hydrogen-powered vehicles have done better in European and Chinese markets, and will soon become widely available to consumers. If current projections hold true, the United States won't see many for a few years. As always, challenges exist. One of the primary roadblocks that have hindered the widespread adoption of hydrogen fuel cell vehicles has been their high cost. This, in turn, has limited their availability to consumers, particularly those on a budget. The good news is that ongoing advancements in technology and production processes are gradually chipping away at this cost barrier, making hydrogen vehicles a more economically feasible choice for environmentally conscious consumers. Another pivotal obstacle has been the scarcity of infrastructure supporting hydrogen fuel. The lack of facilities for producing, transporting, and dispensing hydrogen has left fuel cell vehicle owners grappling with the inconvenient search for fueling stations. Yet this challenge, too, is undergoing transformation, with investments and initiatives aimed at strengthening the hydrogen infrastructure network and making it more accessible to all. In addition to the financial and infrastructure challenges, there have been technical hurdles, especially concerning the durability and reliability of fuel cells and the safe storage of hydrogen in vehicles. However, progress is being made on these fronts as well, with ongoing developments in fuel cell technology and safety mechanisms that promise enhanced vehicle performance and safety. Despite these positive developments, it's essential to acknowledge that hurdles still persist. The most pressing one is the need to make hydrogen fuel cell vehicles even more affordable, ensuring they become an attractive choice for a wider range of consumers. Additionally, expanding the infrastructure for hydrogen fuel production and delivery remains a priority to meet the growing demand for these vehicles. In the grand scheme of things, hydrogen fuel cell vehicles are steadily gaining traction as a cleaner and more sustainable alternative to conventional gasoline-powered cars. As we move closer to a greener future, It's worth keeping an eye on the ongoing advancements and investments that are gradually transforming the hydrogen vehicle landscape. With the potential to overcome their challenges, hydrogen cars are poised to be a wise choice for your next vehicle purchase, promoting a cleaner environment while maintaining your mobility needs. As the world confronts the urgent need for sustainable and eco-friendly transportation options, hydrogen cars are emerging as a viable and compelling choice. With their zero emissions, high energy efficiency, long-range capabilities, and potential for technological advancement, hydrogen cars offer a promising alternative to traditional gasoline vehicles and electric cars. While challenges like infrastructure development and production costs persist, ongoing research and innovation are actively addressing these issues. When considering your next vehicle purchase, exploring the advantages of a hydrogen car is not just a choice for today, but a commitment to a greener, more sustainable future on the road. As the automotive industry continues to evolve, hydrogen cars are poised to play a significant role in reshaping the future of transportation. Whether this approach will benefit Toyota in the long term remains to be seen. However, one thing is for sure: the Japanese automaker is sticking to its guns and will continue to commit to a future that involves internal combustion engines, whether naysayers like it or not. What is your opinion on this subject? Let us know in the comments down below. That's it for today, and until the next one, drive safe.